If I recommend you to stay in Paris for 3 nights, you'll get the price of 3 nights, which is quite expensive. If I recommend you to stay for 1 night, you'll see a price that's much cheaper and maybe will encourage you to continue looking for properties. It's quite costly to test the models online.
You said that your team experiments with everything, runs A/B tests, even for bug fixes. How was your experience when you joined this team?
So I must say it was quite shocking for me.
What was the most surprising finding about human psychology that you encountered in your work?
Oof.
Hey, Causal Bandits. Welcome to the Causal Bandits podcast, the best podcast on causality and machine learning on the internet.
Today we're going back to Tel Aviv to meet our guest. As a child, he teamed up with his grandfather to design his own version of Monopoly. He always loved to build, but didn't want to become a purely technical person. That's why he enjoys working on personalization and recommendations for real humans. Senior Machine Learning Manager at Booking.com. Ladies and gentlemen, please welcome Mr. Dima, Goldenberg. Let me pass it to your host, Alex Molak.
Welcome to the podcast, Dima.
Thanks, Alex. Hi.
How are you today?
Good. I think it was a very interesting day today. Had a lot of meetings as usual. Also some conversation with you, and we're right before the holidays here. So try to get a lot of content at the same day and meet as many people as possible.
Mm-hmm. When we traditionally learn about recommender systems in machine learning courses, those recommender systems are presented as predictive devices or associative devices. In your work, your and your team's work, you merged the idea of a recommender system with causal inference. What can causal inference bring to recommendations? What benefits?
I think, first of all, if you take the story in the right sequence, the fact of trying to do personalization and introduce personalized recommendations to the customers and to the users is a very key concept in any e-commerce platform. And you can think of this of like, hey, I can build a system that can predict what's the most suitable item, what is most suitable recommendation for you. And the idea behind it is that if I'm using classical correlation-based methodologies, I can come up with a better recommender, get a better accuracy, get a better recommender systems metrics like accuracy top K or something like this. But then you face the reality. You need to find out the application itself. So many times what we do is test all of these applications, basically any change on the website, but in particular, any machine learning solution and recommenders in an A/B test and try to see how it changes key metrics that we care about. So we're trying this on high scale. And many times you learn that although you built a really good recommender that can improve the accuracy of the previous benchmark and find the most suitable item for each of the customers and the users, it might not move the needle in a causal way, because what you could do is just move traffic from one part of the website to another, change the behavior of the customers, or maybe just make something that is evident for them. So technically, I just recommended you the same destination that you plan to go in any case. So why would it have any change and incremental impact on the go? So that makes us think about how we shift the behavior in an incremental way. How do we introduce a change, treatment to the website or to the experience of the customer in such a way that they would do something different from what they would do if we didn't do that. And to be honest, that's not something that's super intuitive to think what would happen if I didn't do that. And especially if you're working on recommenders, you have so many alternative options of what would I do different. What you need to think about is how do I change the behavior? What's going to be incremental here? And what's going to make the customers change the behavior and maybe react differently? And in this case, maybe what I want to do is not necessarily to find the most popular, the most frequent solution in the database that's going to fit the customer needs, but actually what's going to be innovative and change. So it starts with the fact that maybe I want to set up the recommendation problem in a different way. I want to find maybe instead of popular destination, something that's trending, something that's going to incentivize the customer to change their behavior. Or if I even want to frame it in a different way. So I would say the role of the recommender, why you're even doing this presentation on the website, plays a lot of role. How do you frame it in terms of user experience, the copywriting, in terms of timing, and how do you place it? And many other things that actually you think about them as something that's going to be incremental, change the behavior of the customers, and not just predict the things that you already know. And many times you do see this causal effect of this expected correlation, that by the fact that I'm surfacing up the most relevant items, if it's destinations, if it's hotels or anything else, if I'm finding something that's more relevant to the users, it's going to be easier for them to find what they were looking for and make this incremental reservations on our platform. But at the same time, many times, just by the fact that you're relevant might be not enough to change something in the customer behavior.
So you're talking here about thinking in terms of counterfactual outcomes rather than just predicting something that is likely for a given user to, their behavior on the destination that they would like.
Exactly. Well, you need to focus on something that actually gonna change the outcome between A and B, because I think we're doing a lot of A/B tests. We run hundreds or even thousands of A/B tests in parallel sometimes, and trying any change that we do on the website, starting from copywriting and UX to bug fixes and obviously any machine learning models or something like that. So you need to build this change in a way that you're expecting to see significant difference in the metrics, and it's also quite harder when you keep improving and have this quite optimized. So I would say you need to find the things that's actually moving the needle a lot. I would say that as we expand into new markets, new types of products, etc., we also found out that in travel, people like a lot driven by price differences. So anything related to discounting, promotions, coupons, and things like that, that's actually something that changed a lot the behavior of the customer. And it also became one of the biggest strategies that we have in terms of let's try to offer more value to the customers by maybe even funding some of the travel options and giving discounts, which is going to change the behavior. And we've seen that in many cases, changing the affecting the price, giving discounts, could be much more beneficial, much better to incentivize customer to book rather than being just relevant. So this is a really good opportunity to extend your customer base and increase the volumes. But obviously it comes with a price, right? You can't just give discounts to everyone. You're going to lose money. So you need to play this optimization game and to understand when it's beneficial and you need to give the discount or maybe what discount to give and when not. And here comes the contrafactual problem, exactly like the point that you raised of many times you might say, okay, let's just give discounts to the customers that are less likely to book, right? We want to convince people, so let's focus on the weakest segment that we have. That's the main gap of understanding that people don't see, that instead of just finding what is the segment that you need to give because they're less likely to book or something like this, you need to understand what would happen with and without the treatment, and obviously with the discounts as well. And I think it's actually a very common problem in causal inference or causal learning to understand what would happen if I give a discount, what would happen if I didn't give the discount, and to figure out if I'm changing the behavior of the customer or not. Because optimization-wise, from the perspective of the marketer, if the customer would book anyway, you probably don't need to give a discount. You want to make the original outcome of the problem. And you want to give the discounts only in a case where you're changing the behavior of the customer in a positive way. Obviously, it's also not such a dichotomic problem. Many times it's just probabilistic and changing probabilities, but you still want to measure this effect. I think maybe what's different in the kind of discounts we're talking about compared to other promotions that you might have is also the structure of the cost. Because in many cases, when you go for a marketing campaign or something like this, the fact that you're targeting a specific population or the fact that you're merchandising a discount, you might have a cost associated just with the fact that you're doing the treatment. For example, sending a physical letter to your customers or paying per click in some campaigns. In this case, we have more like a setup of a trigger cost. So if the customer actually likes your offer and books, then the cost is triggered and then you have to pay the cost, but you also have the booking. And if the customer won't book, whether it's because of the fact that you showed the incentive, which is quite weird, but it sometimes happens that promotions and discount can confuse customers and basically scare them away from the platform, or whether it's because they never had an intention to book in the first place, which actually quite common. In e-commerce, the conversion rate is quite low. I'm not even talking about bot traffic and some automatic sessions that not expected to generate any bookings at all. In these cases, you don't have the cost. So you're mainly focusing on the cost factor of the customers that booked, and then you need to give the discount and you associate it together and making sure that was beneficial to offer that.
That's also related to another topic that is present in your work, in your team's work, that you are operating under some fixed budget or some budget constraints, maybe talking more general.
Yes. So in a sense, because the promotions are associated with cost, we can't just give the discounts to everyone. We need to control it in some way to make sure that we're not just constantly losing money, but as a growth strategy of the company, we still want to utilize as much budget as possible. So the budget that was either given from the beginning or maybe even something that's self-funding campaign, something that can be incremental, to give the discount to as much customers as possible. In a sense, it's an interesting win-win game where you can have a self-funded campaign and by this give more value to the customers and actually get more discounts from that. But because you have this constraint, you have a quite interesting problem that may be not very common in the industry, where most of the industry would just try to optimize the profit of the incremental profit of your campaign. In our case, we're many times looking about incremental volumes, how much new customers you bring, how much new reservations you make, while at the same time you control for the incremental cost. So I don't want my budget to exceed the predefined budget, or I don't want the return to investment to be below a specific threshold. And in this case, if you have a spare budget, extra budget, you actually want to reinvest it and to get much more incrementality. So it creates this kind of like two-dimensional incremental game, where in one side it's very clear, right? You have the binary outcome of let's give a discount and see if customer books or not. And on the other hand, you have the outcome of the promotion in terms of cost. It could lose you money because you could just give a discount that if you wouldn't get it, you would make more money. It could also bring you more money and be incremental in revenue because the fact that you gave a discount made people spend much more on your platform, and it's incremental. So by selecting and understanding how to allocate this in a clever way, you have this optimization problem where each session, each interaction, you have incremental value and incremental cost. And it actually brings you back to like very fundamental optimization problem of knapsack problem. Which items should I pick? Which items I can't pick? And how can I fit within the capacity budget constraints? So it's also actually a very nice mixture and combination between causal inference, which is one field, to an optimization, which is completely different field, and they come together in a very nice way.
That's great. And I think that's very interesting. What were the main challenges in your journey to combine this optimization perspective with the causal inference perspective and the recommendation perspective?
So it's actually quite funny because like I used to work in each of these fields separately. I learned a lot of causal inference when I first joined the company and did a lot of A/B tests and worked a lot on incremental measurements, etc. I used to do a lot of optimization work. Well, even in my studies, I had a lot of like combinatorial optimization background and obviously machine learning and recommendations. But looking at the fact that I need to solve some problems and start to use each of these components separately or suddenly all together, that's what was bringing it in a really nice symbiosis and where you can interact and use all of them together. And the applied part is quite different from the theoretical optimal solution because if you know the knapsack problem, you pretty much know that, hey, it's NP hard. It needs a solver to solve it, and we don't have a good solution for that. At the same time, you have approximations. So you're just using this fractional approximation of like how much value divided by how much weight, and you can sort your outcomes. Then on the causal inference, you learn a lot of papers and research of how to do uplift modeling, how to basically find the right segments to target, etc. In reality, it's harder because the data is super noisy. You have a lot of overfitting, you have seasonality, and you're trying to bring it all together to make it work for the business outcomes and to make impact on where you actually need it and to fit the business needs and not just solve the hypothetical theoretical problem. I think in this point, it's also very interesting that from one point, you're working in a dynamic environment where basically you can deploy the changes fast and see the reaction of the customers, how and the business itself. And at the same time, you learn that the problem evolves. Because usually when you kick off with like, hey, I want to sell as much as possible within this budget as a starting point, you figure out that once you deploy this solution to production, even if you get the exactly right answer of the exact right problem you got from the product people, you suddenly see new constraints of like, hey, I want this segment to be more dominant in these results. We have some fluctuations in the seasonality or something like that. Maybe you want to deploy this solution on more platform or more products. So the problem is evolving all the time. And you not necessarily solve it by introducing new variables to the mathematical formulations. Sometimes you just solve it again and again and again in a different setup. Sometimes you're not looking for the optimal solution, but maybe for the most robust solution that will be helpful and reusable across different scenarios. And many times you just need to monitor the outcomes and to make sure that you're ready and prepared for these changes, because they will happen. You don't know how and when, but you need to make sure that you're ready for that. I would say maybe one key difference in experimentation about discounts, promotions, and anything related to pricing compared to, let's say, UX changes or even deployments of other systems is the fact that the environment is very dynamic. So making a change and then just like ship and forget is not really an option. Many times you need to monitor it, you need to compare it to an holdout. So that's quite a common practice to see over time what would happen if I didn't give this discount compared to the fact what would happen if I give it in certain way, one way or another, and to see how this evolves over time, how it changes, because the business evolves, lots of moving parts around. I just mentioned that we have tons of experiments happening in parallel. Even the dynamic of the promotion itself might change. And I think this is something that's very important in any applied machine learning, but I think in this case specifically, to connect to the understanding the customer. Because first of all, we're doing it independent assumptions that we have from the original data are not really the case when we're dealing with real users, real problems, and we need to control for that. I would say that we not always know how to control for that. Mm-hmm. So I think the first thing that you need to do is to acknowledge them, to understand that you have these gaps. Many times we have really nice models in offline evaluation. We build cool uplift models, have really nice Kini curves, measuring the best performing models. And then when we deploy them in production, we see some problem. And the more understanding you have what makes the difference and misparity or parity between online and offline, the better you can improve your models offline, because it's quite costly to test the models online. Eventually we're giving discounts. So if you're doing it in the wrong way, you might get misoptimal results. So it's better to test and train these things as much as possible offline.
What are some of the most useful strategies, or the strategies that you find the most useful when it comes to evaluating models online and learning from this online evaluation in order to translate it to something new in the offline evaluation?
Whoa. So that's a lot. I think the first step, and that's actually quite a boring type of work, but very important and very necessary, is to align two fundamental things. One of them is to make sure you're having the same metric online and offline. And while it sounds trivial because it's coming from different sources and timing, etc., it could have quite different definitions. That's one. And the second one is the same with the data. Make sure that your data collection process for the online and offline processes is the same, and you don't have some fundamental biases or gaps between the two. And just by that, you're making sure that there's alignment between online and offline. And I would say the best way to test it is kind of like make sure that you have a very simple baseline offline, running offline, and have this number, and make sure that you're able to get exactly the same measurement when you're running it offline. And if you're not, that's also fine. But you need to understand how much is this gap and that you can predict and expect it in the future iterations. Now, besides that, what we try to do is kind of like to do continuous experimentation. So it's not enough to test some specific treatment in a specific period of time, but actually we're trying to run it continuously to see that the gap between the no treatment and treatment or one treatment to another stays the same. And if not, we try to react to that. So this is another solution. And many times what we're also trying to do is to build a bit more robust solution in a sense of portfolio approach. So we not necessarily have one treatment that is the optimal one and meets the exact threshold of what we set with the business, but actually several different strategies, sometimes very diverse, sometimes coming from the same methodology. And by that, you kind of like ensuring that you always have at least 1-2 working methods. So if something breaks, you can still rely on one or another. I will say that eventually also something that we've seen working a lot is the fact that you need to stick to simple models. It's really nice to go like to tons of features, very complex models, and have really nice benchmarking offline. But then when you deploy it, first of all, you have a lot of problems with the deployment. Then the more features, the more parts you have, moving parts you have, the harder it's to maintain it. And also it makes this like problem of overfitting much more complex when you're moving on, because basically any new variable that you add might have drift, might have seasonality, might affect differently on the outcome eventually.
There's a lot of, there are many moving parts here, and the more variables you add, the more adding more moving parts you risk. You said that your team experiments with everything, runs A/B tests, even for bug fixes. How was your experience when you joined this team and you met this culture for the first time?
So I must say it was quite shocking for me, and I joined this like experimentation culture where it's everything is data driven, and just show me the data and you'll get the chance to deploy your solution, and everybody is right if you have the right data to confirm it. But it also creates a nice evolutional game, I would say, where the best solution, the one that proves to be better over time, is the one that survives and evolves. It's also quite intimidating because you have lots of, as I mentioned before, lots of moving parts, lots of teams that working on similar or different directions, and you need them to converge together. Sometimes it even creates some parts that could look the same and could even compete with each other on the platform. And then again, you can many times see with the data which one is better. And I think over the time, also with the involvement of my team that is part of a central department that tries to build these solutions for optimization across the business. So for different use cases, for different problems, is to see which parts are useful and repetitive between different solutions, and to deploy them either as common methodology or maybe as a common platform and give them as a service to the rest of the teams. And eventually it's also encourage a culture of collaboration, because you see somebody solve the problem better than you do. You learn why, how, which features work, how do you do the experimentation. And you evolve with this over time. I think in general, what we have at Booking is a lot of causal inference, causal learning problems where we're trying to understand what changes, what strategies would work better than the others. And we have this opportunity to share the knowledge with the rest of the community. We have quite a big group of scientists, data scientists, machine learning scientists working on these problems. So coming down with the things that work together for other teams, different teams, and collaborate on these solutions helps eventually to improve all the different products across the business.
Mm-hmm. You mentioned a lot talking to business. What are the main lessons or main insights that you could share with the community regarding communication with business stakeholders as a person who is representing a technical team?
So I think that we started that from the beginning, from pretty much the first question of what is recommender system. And I think you need to understand what is the expected impact of your work. I think many times when you're working on machine learning, especially, by the way, not in the causal work, but let's say in many other domains like even content, NLP, vision, maybe even in recommenders, many times as machine learning scientists, what you're trying to do is to optimize the accuracy of your algorithm, right? If you're doing, for example, image recognition and you're trying to recognize object in the picture, you're trying to improve the accuracy of your classification model. But what's really important is how it's going to be used, where it's going to be deployed, what is the effect. So for example, if you have a really good model that can recognize toilets in the picture, that's nice. You can get to 99% accuracy. But if you don't know what is the use case and how it's going to be used, it's going to be really hard for you to move the needle. And I think this is a key in everything we do in terms of deploying machine learning, connect it with the actual product need. That also means that we have quite mixed and interactive teams. So you always have a product manager assigned to your team, trying to basically not just take the models and deploy them to be the most accurate, but actually change and move the needle in the important business needs and connect this model. So if the toilet model recognizing toilets could be useful for you to maybe onboard new small properties on the platform that didn't tag all the amenities they have in a good way, then it's a good win for the business. And you also need to understand this in a scale of like how important this change is going to be. Many times you might have good progress in machine learning, which has a little to do with the incremental value to the business, to the company, to the customer. I think that's also a very important part because you're talking about the business, but eventually as a marketplace, the people who benefit from the outcomes are either people who come to book on our website and the customers that enjoy from this experience, or people who put services on our website like hotels or other stuff. So you need to think about it from the perspective of like what they benefit from this, which is nice because it correlates with the business needs. It correlates a lot with the fact that we just want more deals to happen. And we assume that everybody is happy once somebody finds the right place to stay.
What would be your advice to people who would like to improve, technical people who would like to improve their communication with stakeholders, specifically people working in causal inference, so people trying to understand the mechanism from the technical point of view?
I think not to fall in love with the machine learning work, with the cool technical stuff, because I would say I've seen a lot of cases where actually the simplest solution, the simplest baseline solution, deploying some average result, deploying some not one number, magic number, something like that, could have a huge impact on the results, on the customer behavior of what should happen, etc. And many times when we're trying to train models, get into fancy stuff, get into deep learning, etc., maybe we should do this, but not at the first step. At the first step, we really need to understand and even get into this like position of like, what would I do if I didn't know any machine learning at all? And I actually can give you a cool example that's related to causal inference, but take it from a completely different perspective. So I mentioned that we did a lot of recommendations of destinations of where you should go. And one of the sub-problems of this problem that we try to solve is, let's say we recommended you to go to Paris. For how many nights we should recommend you? Because eventually we need to generate a link that when you click it, it's going to get you to the place, hey, let's book a property in Paris. And we had a really good model that sees the distribution of how many nights people book at Paris. By the way, it's at least 2-3. Like people don't stay usually one night there. And we've seen there's like popular time of that people spend on in Paris. And we try to deploy the solution for each city, maybe even contextual. We can say for how many nights we recommend to stay there. And then we've seen that it didn't help the customers. It didn't make people book more. It didn't have people to navigate through the page. And basically, it's not the right answer. Although we see that in our use case, in what we've seen the data, that's the right answer. We need to recommend many nights. And one of the things we realized is that it has a lot of side effects, a lot of other potential things that could affect people's decision. I'll give you an example. If I recommend you to stay in Paris for 3 nights, you'll get the price of 3 nights, which is quite expensive. If I recommend you to stay for 1 night, you'll see a price that's much cheaper and maybe will encourage you to continue looking for properties. The same, by the way, goes with availability. There's much more properties available for 1 night than for 3 nights, just because of availability concerns. So in reality, what we see many times is just by showing 1 night might be much more beneficial because it keeps people to stay, to dig more into the experience, and not necessarily the most accurate answer is the right one. And that was quite funny realization because we worked on this project, I think, for quite a long, and we figured out that there's like the simple answer was always there under our nose.
That's, in a sense, beauty of causality, right? We can come with a hypothesis, and then we try to see if our hypothesis works well with the real world, and we get an answer from the real world. And in this case, the answer was no.
Yes, and I think in this case, causality is also not only about, discovering dynamics of like a complex world of like action and reaction. It also has a lot to do with human psychology. Not necessarily rational, right? Because probably the right amount of nights to stay in Paris is 2 or 3. But actually what makes people change their mind, what makes people to get to the desired action. And by the way, it's not that easy to define what is the desired action. Obviously, when you're trying to sell hotels or something like this, probably you want people to book more. But in some cases, it's not that trivial, especially if you're working on other areas of the platform, like customer service or anything else. So to understand what drives people to move towards the desired action, many times you need to involve, first of all, interviews with the customers, UX, user research around that. But sometimes they don't even know that you themselves. So they make these decisions irrational, wouldn't confess that that's the reason why they're making this choice, and you just see it in the data. So it's also the beauty of running experiments and just uncovering what happens there. Sometimes you feel like you hack the mind of the people and you're like, whoa, so that's what happens. That's actually the patterns, the behavior that happen, and many times it's counterintuitive. And the fact that you can connect between people behavior from one side and the data and the results from another side, I think it's also one of the most exciting parts of my work.
What was the most surprising finding about human psychology that you encountered in your work?
It's going to be hard to point at one particular thing. I tried many times to test different, cognitive, I would say urban legends of what happens with, choice overload or price comparisons and other stuff with users. I would say, without even pointing a specific example, I would say that it's inconsistent. And you see it a lot of even running a very successful and significant experiment on one setup, one platform. Kind of you have this excitement of hey, I finally proved it, that maybe I should show it in this way, present the user experience in red color, in blue color, whatever. And then you're trying to repeat exactly the same experiment on a different platform. Let's say it worked for me really well on laptop. Now I want to make sure that it works the same way on the apps. So you're super confident, you deploy exactly the same experiment, changing, let's say, the color of the button or adding a pop-up. And you just see completely inverse results, and you figure out that, hey, wait a second. So it's not that consistent, or maybe you see that people from different countries react differently. Or maybe you sometimes see that just the same person half a year later could have a different effect. So I think, actually, I would say the most surprising fact about human psychology that it's not super consistent. It's really hard to predict. And while you do learn patterns, you still need to make sure that you validate it a lot. And I think at the beginning, I was really confident with lots of claims that A causes B, and trying also to sell these ideas to other product teams of yeah, you should do this thing. And I think the more I work on these problems, the more I kind of become humble and understanding of wait a second, the fact that it worked for us, not necessarily going to mean that it's going to work once again if you repeat this. It could be about using a specific machine learning methodology, could be about measurement, it could be about changing UX differences or anything. But that's the beauty of that we have the opportunity to measure the results. So you could always say, maybe it's going to behave like this, let's test. And I think this is kind of my go-to approach. We have some hypothesis, we want to try it, we have some hinge of we want to have this thing working this way, but the final solution, the final result that you're going to measure, it's going to be on the actual causal A/B test that's going to show you that, yeah, you were right, that works, this one didn't work.
It also shows us the limitations of A/B tests, right? That the external validity is not something that we can take for granted. In terms that if in one environment we have shown the effect, it doesn't automatically translate to another environment or another population.
Yes, I think when you read papers, especially like, again, let's go to psychology papers that come to conclusions that, I don't know, that people from a specific race would prefer a specific color or specific gender would do that and not that. You always like, open up like, hey, who participated in this particular experiment, when it was done, by whom, what is the background of the people? Because yes, maybe the result that you've seen is significant. Maybe for the specific people that you ran this experiment, it was actually significant and different. But if you want to replicate these results, many times you will face different problems, whether even if I'm trying to test exactly the same thing, but I'm doing a small tweak and not in the way that the recipe said, and you need to validate it again and again. Which, again, I would say that in business environment, when you're trying to improve your platform, you need to keep evolving and you need to keep monitoring the changes, because even if it worked really well for you a couple of years ago, it doesn't say anything about how it's going to work now.
For people working with causal inference, whether it be experiments or observational data or mixed observational and experimental data, it can be sometimes challenging, especially if they're new to the field, to get used to this idea of thinking in counterfactuals, comparing those counterfactual outcomes. It seems that it might violate some of our natural inclinations or natural intuitions about how to think about causality. What's your experience with this?
So first, I would say it's also hard for people who experience in the field. Like me and my team, we're working on this like uplift modeling, causal inference for the last 3, 4, 5 years. And still many times we face this dilemma of like, wait, we never thought about what would happen if we didn't do that. And I think this kind of thinking requires you an extra level of cognitive load, of understanding that there's a completely different scenario, that I could do completely different actions and the outcomes could be different. And you can fall into this when you're trying to build a treatment and to understand that like, hey, I'm not looking at the causal effects, I'm looking at just like specific thing. But from another side, you also never have these two scenarios at the same time, right? You never know what would happen if I do A and if I do B at the same time. You don't know what would happen if I give the coupon and don't give the coupon at the same time. So you never know what would be the actual outcome. So kind of like randomized A/B test helps you to do that, but still you don't have this particular specific person, specific change happen with the same people twice. And it's also hard, when you're modeling it. So even if you get into the side of like, let's evaluate the models, let's understand is the model is good or bad, you don't have true labels. It makes the explainability of the model harder. It makes the monitoring of the model harder. It makes the benchmarking of the model harder, because you don't really know what would be the optimal action. You do get it sometimes when you get into simulations. This is a game we like to do of like, hey, let's just simulate a world when you have the outcomes of both scenarios and to understand which one would be better. But this is a very much like, extensive thinking and kind of like our way to come to a solution that it's hard for us to grasp it. Now, if you take it to, to normal people that don't get to use with causal inference all day, contrafactual are even harder. Like if I'm looking at different decisions that I had to do back in my life, like some dilemmas that I faced, like whether I should study that or that, you don't really build this scenario of like, hey, like there's like this turning doors that I'm gonna go to scenario A and end up like that, and go to scenario B and end up like that. So it's really hard to understand what would happen if you didn't do this. And you face it like, but once you grasp it, you can see it everywhere, right? You can understand it in when you're getting into supermarkets and you see like some deals and you're understanding, wait, so they give this discount and now they can sell much more. They actually make me buy some, some cheese that I never planned to buy if they didn't have this discount. Or you can see it in public policies of basically some incentives, some changes in the policies that make people change their behavior and, pay more taxes even in some cases, or buy apartments earlier because they know that tax is coming. So you see a lot of things of what would happen if you do something differently, and you see these policies, but it's very easy to be like, smart in retrospective to see people doing, changing the behavior and moving into a different direction. you not necessarily predict this behavior in advance, especially if you're the one that makes the policies.
Yeah, I think that there's so much to talk about when it comes to human psychology and counterfactual thinking and causal thinking, and there's so much interesting research on this. I would like to take a step back now and get back to the point where we started our conversation. So go back to this idea of causal recommender systems. If you could give a short introduction to those people in our audience who are not familiar with your work, what kind of ideas or what kind of technological building blocks have you used in your work on those recommender systems?
So I would split it because there's the department of causal recommender systems, which I would say could be another podcast and we can talk about it a lot. I think that what we're working on is a bit more simplified version of it, of at least how we call it uplift modeling. It's also sometimes referred as a heterogeneous treatment effect, of basically trying to find the conditional average treatment effect of some treatment. So you have a set of treatments. It might be just 2 treatments, like discount, give or not give. It could be multiple treatments, like what should I give? And then you could get closer to recommender systems. And basically, when you're trying to solve this problem, you need to understand which outcome is better. And better is also depends on which metrics do you define. Sometimes if you have just one metric, it's quite easy. You just measure which one is better. If you have multiple metrics, then maybe you need to do multi-objective optimization. Maybe you need to do some kind of Pareto trade-offs between the different tools. So we start, and the nice part that we almost always start with randomized data. Technically, you could do also a lot of causal inference and causal recommendations from observational data. And it happens a lot, especially when you're doing things like ranking, recommendation. You always have biased data, unless you're doing full randomization. But even then, you might have some bias. So if you have biased data, you need to debias it in some techniques, either inverse propensity weighting or some other techniques and approaches. But you need to come into the understanding of how do I debias different problems that I have in my data. If you're starting from scratch and you have, let's say, just 2 treatments, it might be easier because you're starting with a randomized data set. So you have treatment A and outcome of treatment A, treatment B and outcome of treatment B. And then you can measure, first of all, the average treatment effect. So was treatment A better than B or the opposite? Let's say we're offering discounts. Many times it happens that people prefer discounts and like them. So they book more, they have a better outcome with the discount. And then we get into the problem that we might have too many discounts that we gave away. We need to balance it and control it some way to fit into the budget. So, by the way, without this constraint, it would be an easy, trivial solution, which some people don't think about. Sometimes it might be okay that just to give the treatment to everyone and everybody's going to be happy with that. We not necessarily need to start again with the modeling. Maybe the trivial solution could be good enough. So then you get into another problem that you can't or shouldn't give the treatment to everyone. You need to balance it. So first of all, it could happen that not everybody has a positive outcome of the treatment, right? With discount, it's quite straightforward that people prefer a better price. They prefer a discount. So many times the discount will have positive effect. Sometimes it doesn't, especially if the discounts offers you a product that you never planned and then it just takes you completely off the plans that you try to do. But in most cases it is. And then if you could give the discount to everyone, that's good. But if you can't, then you need to understand who is the most suitable segment for this, how you can optimize it. And by the way, the segment doesn't necessarily have to be user segment. It could be anything else. It could be based on other properties. And then you need to find a way that says what would happen if I give the discount and what would happen if I didn't give the discount, which is the causal modeling eventually, the uplift modeling. One of the ways we're doing that is by using a technique that was developed at Booking, retrospective estimation, basically training an uplift model just from the converted data. And with that, we could understand how we could, who should get the discount and who's not. And we find that it eventually gives you some kind of SOTO. Okay, so basically, what is the potential impact, potential outcome of each individual. And by that, again, if I can give as many as possible, I would. So I need to find what is the right threshold, when to stop, and what is the segments that are going to be affected and what are the segments that are not. That's done usually with causal measurements like Kinney curves, when I'm trying to understand what is the optimal threshold point. And with that, we usually go to production and see if our policy is right. And I think the fact of tuning the offline outcome and comparing it to what's happening online, that's let's say a separate type of expertise, I would say, that you need to learn and iterate, and many times learn from mistakes and from application that could be different from case to case, from company to company. But I would say that the key for that is just to see what happens and react to the data.
As a kid, you like to build stuff. How does early experiences in building stuff, designing a game with your grandfather, how does this impact the way you see your work today?
So that's interesting. I think that, we take this anecdote of one thing that I did is I've seen other kids have the Monopoly game and didn't find where to buy it even. It wasn't even a problem of can't afford it. I just didn't find. So we decided with my grandpa to build this game ourselves. And we had the first version of this. I went to the backyard to play with kids. We were, I don't know why we didn't play with the ball. We just sat and played with that, but okay. And I found it too easy. I played with the original Monopoly. I remember how fascinating it was, and this one was too easy. So I guess I came back. I think it was I was also going to my grandpa, so it was a month after month after month. And we decided that we want to make it a bit more complex, a bit more rules and a bit more constraints. And the game became more interesting. We also seen that some mechanism doesn't work. Some of the design could work differently. It wasn't necessarily about economy or of other stuff of Monopoly, just how fun it is. And I think if you're trying to find the analogy of the work we're doing today, I would say, again, you try to solve a very complex problem, okay, with lots of moving parts, sometimes big budgets, lots of customers. You should start with a simple solution. And it's definitely not going to be the optimal solution. I think that's the biggest gap between academia and industry. You need something that is better than the current one. You try it, you learn from this, and you start to introduce more and more complexities. For example, when you're doing promotions allocations or discounts, you can start with the simple understanding of can I even give this promotion? So just run a test and see what happens. See if it's beneficial, if it's losing money, if customers react well for this. Again, many times the problem or the key is even in the UX and how you communicate it. And let's assume it works and you want to allocate it, optimize it. You would start with simple lever give or not give. So when I should give it, when I shouldn't give it. Then you can make it a bit more complex and get into the point where you can have another lever. Maybe which promotion to give. Maybe I can give different discount levels. Maybe I can offer promotions on different products. You can make it even more complex of when to give it or in which part of the user experience. Maybe I should give it at the beginning of the journey. Maybe I should give it at the end of the journey. Maybe we should do this as a incentive that comes later. So the timing could play a role. And you can make it more and more complex by introducing more and more levers, even on which items. Maybe I shouldn't give the discount to all of the items. Maybe I should give it only to some. And the optimization problem becomes very complex. Sometimes you solve them independently and hope that it's just going to work. Sometimes you're trying to build a complex system that's going to take into account some of these moving parts together. Most of the time it doesn't work, but you still have some approximate solution of how it works. So I would say that seeing how this mechanism evolves and also seeing how the reaction and the feedback is something very interesting in designing such systems.
It sounds like you were engaged with this game with your grandfather in a really long-term project. It was not something that happened over a day or two.
Yeah, that's because the friends that I had over there, it's it was in a different city. So I was coming over for a weekend or for some vacations and playing with other set of friends, and and then I had like a break of a week, a month or two that they were in between. So every time I came back, it was completely new game. Yeah, I wouldn't say that this this part was very much life shaping, etc. But if I try to remember these games of monopolies, I remember that we had several iterations of that.
What keeps you going today?
Oh, that's interesting. First of all, I think it's just enjoying your environment, life, work, whatever. Here at Booking, for example, I'm almost 7 years here, and I really enjoy the people, the environment, the individuals that I interact with, the team that I have, people in my team, people in teams that I interact with, and just beside the fact that they're super smart, I also just enjoy spending time with them. So I think that's something that drives me a lot. And I would say that on the professional level is that you have a lot of opportunities to try stuff, to keep learning, to see how it works, to see how things react, and kind of keep exploring, keep learning new stuff. And I think particularly I'm quite lucky that I have the opportunity to test different experiences on very big scale and see the world of data, how it reacts, and really see big volumes of things that moving and changing. And in particular, making this impact on lots of travelers, seeing it's changing a lot of stuff. And even we're talking about something that I'm using on my day-to-day as well. My parents planning a trip, they're also using the same tools. They see my work. So I think it's very cool that you see this almost feedback loop of the work that you're doing and the feedback that you get from either the immediate, metrics in the work or even from your friends.
What would be your advice to people who are just starting with causality, causal inference, or machine learning in general?
I think I repeated it a couple of times, but first of all, keep it simple. Try to understand what are the fundamental things that are shaping the problem. And first of all, understand the problem that you're trying to solve, and only then pick up the tools that you need to solve. Because, I'm working on this quite a lot, and I'm still making this mistake again and again and again. Luckily, I have enough good people, smart people around me that tell me, Dima, you're overcomplicated. But really try to keep it simple and and try to come up with simple solutions. Don't be ashamed of this. I think this is also something that's very typical to people who are starting in machine learning, that they almost embarrass from simple solutions because they feel like they didn't really accomplish what they were hired for. And I would say that it also depends. I think from company to company, from different environment to another environment, maybe different things are appreciated. But in this case, try it, especially if you're working in a business environment that's looking for impact, try to understand what actually moves the needle, what actually changes and important, and then navigate your effort towards that, and not necessarily into fancy cool stuff, but actually to the things that work.
Yeah, today, the deep learning culture promotes jumping into architectures without understanding the problem often.
I think that even then, deep learning is not a bad thing. It's it's super useful, and it has a lot of cool solutions. Even I would say the recent advancement of generative AI, etc. But then again, you need to understand how it's useful for you. For example, how do you connect causal inference and generative AI? It's super untrivial. You could get into the part where hey, I want ChatGPT to just tell me, should I give a discount or not? But obviously, it can just train on my data and understand how it works, at least for now. So maybe what you can do is get some context features. Maybe get something that you couldn't get from unstructured data, introduce it to your model. So you can find some interaction with that, but you also need to be super smart. I would say that when you're saying architecture, I would say that most of the complex problem that you need to solve is not actually about how to design your deep learning network or neural network. Many times you just have pre-trained networks that are doing a really good job. What you actually need to do is to understand how do you plug a lot of different parts that are responsible for different tasks together to solve the ultimate task that you have in your problem. And maybe even connecting back to causal inference, I think that one of the most fundamental things in machine learning that you need to understand before doing any modeling, etc., is the evaluation. You need to make sure that you evaluate the right metric, that it's consistent and correlated what you're trying to solve, that it's useful across the different applications, that it's easy to understand for all your stakeholders. And when you're cracking the evaluation in the right way, it's quite straightforward to understand what you need to improve, and then you only have the problem of how.
What are 2 books that changed your life?
So it's a tricky question. I'm not too much into books, to be honest. I like a lot popular science. I think, like I told you that back when I was in university in studies, I organized a lot of popular science talks and actually was exposed to a lot of super smart people that were talking about their books, but I barely read those books. I think 1, maybe 2 books that actually helped to shape a lot of the things that interest me is related to, let's say, cognitive science and rationality. So one of them is Predictably Irrational, I think, by Dan Ariely. And then after reading that, I went to the hardcore foundation of that, to Thinking Fast, Thinking Slow by Kahneman, and that just passed away a month ago. So yeah, that was quite a big change to science in general, and maybe to also my view at again, connection of people behavior, and then what you can learn maybe from data. I took a couple courses to connect again between my engineering data science background to a bit more how people making decisions, how behavioral sciences, and even my research was almost always around these topics of marketing and seeing what makes human behavior change. And again, understanding this pattern, and just understanding the fact that you can really find repetitive patterns in human mind, whether they're rational or irrational, because I think also rational or irrational are concepts that coming much more from economy and optimization rather than psychology, and figure out that that's how it works, and it's repeating from people, from person to person, between people. That's quite cool. And I think, when you working in the field of machine learning AI, you see this coming a lot when you're training models, right? You just models are eventually outcome of what they're exposed to. So what they see in the data, that's what's going to happen. I'm a fresh dad. I have a 6 weeks old child and an older one. So I also have some experience with that. And you actually also, I don't know, maybe that's a professional disformation, but you also see this in kids, right? That they just exposed to examples, to data, and they react. And they're doing mistakes, and they learn from this. And you see how they shape their understanding of the world, right? They see objects moving and first not understanding what that, and then they understand that that's their own hand and can respond to that, and that now they understand they can control it, and then they understand that maybe they can't move themselves but can point in some objects and tell you as a parent what to do. And the fact that they're crying is actually the optimal treatment to get your attention. So that's how they basically optimize their goal, right, of getting your attention, of getting some love from you by crying. I think that you actually see this, that they're trying different stuff, and this is the one that converts the most. So it's quite fascinating to see that that's how human mind works, and this is quite the things that we're trying to teach machines to do.
Who would you like to thank?
To thank? Whew. There's a long list. I don't know. Yeah. Look, I think I'll start with my family, and I learn a lot about this and understand this a lot on the go. But I moved here to Israel when I was 10, and my parents kind of left behind everything. They had quite nice careers and lots of opportunities, and immigrated, moved to a different country with new start. And I think I never felt that I felt like they invested a lot into me. And this is something that I understand in retrospective, not necessarily something that I felt back then. Lots of my education, lots of many different opportunities. So lots of thanks to them. Probably grandparents as well. I just told you this story about building a game with grandpa. I never thought that it would be such a life-shaping experience. So I would say that, the older you get, the more thankful you are for your family. Yeah, I think, and professionally, I would say that I'm really inspired by my colleagues, like whether it's my teammates, people that report to me and like give me new challenges, new opportunities, new learnings every day, people that I have fun with and just, enjoy to spend time. And also other people that there's lots of like learning that you can make from that. So I would say that I would split it into many different people that shape my experience. Obviously, my new family, the kids that help me understand better the world. Obviously, my wife that supports me in all of that. So lots of people from also lots of different perspectives. I think I really like the fact that many different experience from the past have this like connecting the dots sometimes in retrospective. So like you just exposed to some ideas by people and you never understand why it's useful for you. And then, like few years later, you then get to use this particular thing that you learned from that and heard from this person. You might not understand that like a particular thing that you learn from one person at a certain point of time could be really useful and converge with many others learning and knowledge that you see from others people and other experiences. And it's shaping you a lot. I like to look at everything that I learned, every learning opportunity that I had, every course that I take during my degree is something that I found useful later on professional career. I know that many students don't see it, maybe don't believe that, hey, well, like, why am I studying this, like, I don't know, operational research course? It's never useful for me in my like data science work. And then hope 7 years later, you're doing knapsack problem solution and and things like that, or any other experiences that could sound very stupid, very simple, but then it might be helpful, even if not directly, just indirectly knowing this idea, seeing it somewhere, connecting the dots, and makes you better.
What question would you like to ask me?
I noticed that you're investing a lot into connecting with people and kind of doing all this podcast and all this work with kind of I would say a mission behind it of, again, connecting a lot of ideas and opportunities together. And I would say that what would be the greatest outcome that you would expect from just meeting all these people?
Oh, that's a beautiful question. I think I already have outcomes that are beyond what I imagined when I was starting with all of this, with the book and the podcast. I had wonderful opportunities and I learned so much recording this podcast that I never thought it would be possible. But if you ask me about something like the biggest goal, that would be creating a platform that leads to a resource, maybe a book, maybe a series of books that bring together different perspectives regarding causality. So perspectives from continuous optimization, reinforcement learning, operational research, experimentation, formal causal formalisms like Peirce's formalism, and so on and so on. Because I must tell you that I see when I talk to people in different sub-areas of causality that sometimes those people are trying to solve problems that are already solved in another sub-niche, in another little ghetto. And now they don't even know that other people were working on a similar problem, because there is a citation gap in the literature and nobody never cited a person from this other stream.
I notice this a lot, especially even if you're jumping from one discipline from another. So let's say you have economics, you have and you have healthcare. They might have even different terminology for the same things. I think at some point we had one employee that had a lot of experience with heterogeneous treatment effect work, but never heard about uplift modeling. And I think it took us a week to understand we're talking about the same things. We just relying on completely different literature, because they're just citing two different sources and basically working on the same things, but with different formulation, with different terminology, but trying to solve pretty much the same problems. And actually, I think he even wrote this paper bridging the gap between heterogeneous treatment effect and uplift modeling to kind of show how similar they are. Personally, I had this experience of talking about what I do with people from healthcare, And while many of the things that we do sound very similar, you still see that the problems we're trying to solve are very different. So if I'm trying to find the optimal policy, they sometimes trying to look for the most robust policies. And we're using exactly the same tools, we're using exactly the same approach to the problem, but we call it in different names, we evaluate in different names, and I see a lot of opportunities of that converging. And I also connect to the point that you mentioned that like people don't know that the problem is solved somewhere else. Sometimes we don't even notice this, like, within the company. We solve a problem, we're super proud of our solution, we kind of like showcase the solution, and then we hear that other teams just tried the same thing like 2 years ago and it already works. And you have this like kind of like, so maybe we should communicate more. And I think it's a lot about like, building community, talking about this, and even aligning the terminology.
Yeah. And I'm a firm believer in building more bridges between those ghettos. I think we have wonderful opportunities awaiting us there regarding many problems that we are facing today. Dima, where can people learn more about you, your team, and your work?
So luckily, we had quite a lot of publication in this field, specifically in like uplift modeling, causal inference, as booking.com, and causal inference A/B testing is quite a very strong tool that we also talk about, and uplift modeling specifically. So we had a couple of recent tutorials in CIKM and in WWW. We have a couple of papers published in recent years, multiple talks presenting this problem. And in general, we really like to talk to others about how we solve these problems, because we learn a lot also from the industry and how it works. I've seen that the causal machine learning community is also evolving a lot. There's lots of workshops and different conferences. There are lots of Python packages of how to do that. Sometimes they're doing exactly the same, and it's not really clear what's the difference between them, but you have a huge group of people to collaborate on this. So I think if you just look up for some content that we release in Booking at Causal Inference, Uplift Modeling, you'll see a lot. And also personally, I got so excited about this that I actually, after working on all of this, started a PhD and started to research that. So I keep working on creating new knowledge on this topic.
That's really amazing. What's your message to the Causal Python community?
Share learnings, your results, your approach, and don't just think that you're stuck somewhere. Like, talk to others and see if they have a better solution or some solution to your problems.
Dima, that was a wonderful conversation. Thank you.
Thank you.